Good morning and Jai Hind children. I welcome you all in today's live class of chemistry. Children, we are discussing the chapter soil. And in previous class, I have explained the topic types of soil. So I hope that you understood that topic. Alright, now today I'm going to discuss the answers of oral questions first. And the question number 1 is soil is made up of two main components. One that comes from living things and the other from non-living things. What are these components? Alright children, here you have to write down the name of the components. Okay, from which the soil is made up of. So the two components of the soil are the first one, humus. The first component is humus. Humus is the dark brown colored component of the soil and is produced by dead remains of living things. Okay. And the second component is, yes, mineral particles. Alright. Mineral particles include minerals such as potassium, calcium and magnesium. And these are derived from the rocks, which is non-living things. Okay, so these two are the components of soil by which it is made up of. Humus, it is the, yes, it is living things that forms the humus, and the second mineral particles, they are the non-living things by which the soil is made up of. All right, now come to the question number 2, and the question is water expands when it freezes. So what role does this play in soil formation? Children, understood the question? Once again, I am going to repeat. Water expands when it freezes. So, what role does this play in soil formation? Alright? So, children, you know very well the rainwater that enters into the, yes, surfaces of the large rocks, the gaps which are present in large rocks, they freezes in winters and expands, and the expansion of water creates a pressure and leads to the breakdown of large rocks into small fragments, and these small fragments forms soil. Okay, now the question number 3, and the question is what kind of soil will hold more water? One made up of small particles or one with bigger particles? Okay, children. So here you have to, yes, find out that which hold more water. So children, soil which is made up of small particles will hold more water as compared to soil made up of bigger particles. The reason is, yes, because small particles pack closely, which increases water retention capacity of soil. Okay, now the question number 4. And the question is farmers generally like the soil to be a mixture of sand, silt, clay, and humus. Why? And what is such soil called? So, children, the soil that is a mixture of silt, sand, clay, and humus is preferred by the farmers because it is good for the growth of plants. And this type of soil is called loamy soil. Alright, this kind of soil is called loamy soil. And this loamy soil contains optimum water retention capacity as well as air trapping ability, which makes it perfect to support plant growth. Alright? Now, the next question number 5. And the question is, soil is formed by weathering of rocks. What does weathering mean? Children, you have to, yes, define the term weathering. So the weathering is a process in which large rocks are broken down into smaller fragments by the action of natural forces such as winds, water, and glaciers. And the smaller fragments formed by this process form the soil. Get it? So these all are the oral questions first, and I hope that you understood the answers. Now, children, our next topic is properties of soil. So we will discuss one by one the different properties of soil. And the first property is percolation rate of water in the soil. This is the first property of soil. Children, if you spill water on the cement floor of your house, so it stays there for a long time. Is it? You must have observed it. However, if you spill water on the ground outside the house, it quickly gets absorbed in the soil. So this is because water can percolate into the soil. Okay, but not into cement. And does water percolate through all types of soil at the same rate? So to know about it, that how the water percolated by the different types of soil, simply we will perform an activity. And in this activity, we will take three, yes, similar mineral water plastic bottles. Alright, what we'll take? We will take the mineral water plastic bottles. Alright, three. And cut off the top and the bottom of each. And we will cut it from here and here. Get it? So, after cutting, yes, you are left with three similar hollow plastic pipes. So, you will get the three similar kind of plastic pipes. Get it? Now collect about 2 kg each of different types of soil samples at a place and place each pipe in a soil sample so that it is about 2 centimeter deep in the sample. Get it? How many samples will collect? Yes, we'll collect the three different samples about 2 kg, okay, of each. So three different soil samples, and we will place our plastic pipes in it. Understood, children? Now, after putting the pipes in the soil samples, we will measure out 200 ml of water and pour it into the first pipe. We will take a measuring cylinder or beaker and we'll take 200 ml of water and we'll pour that water in this first pipe. And now we will measure the time it takes for the entire water to percolate in the soil. Okay, how much time is taken to percolate all the water in this soil sample. Get it in? And to calculate this percolation rate, we will use the formula. And the formula is percolation rate that is measured in ml per minute. Okay. And this percolation rate will be equal to amount of water percolated amount of water percolated in ml and divided by time taken in minutes. Get it? So this is the formula that we can use to calculate the percolation rate of soil. Okay? Amount of water percolated in ml and by time taken in minutes. For example, if it takes 10 minutes for 200 ml of water to percolate, then the rate of percolation will be, yes, the rate of percolation will be amount of water, how much we have taken? 200 ml. And the time taken is 10 minutes. A little in. And the rate will be 20 ml per minute. So the percolation rate of the soil who have percolated how much? 200 ml of water in 10 minutes is 20 ml per minute. Got it, children? And similarly, we can find out the percolation rate in the other soil samples. Get it? So you will notice that the rainwater that percolates through the soil collects above the bedrock, and this natural level of groundwater is called the water table. Get it, children? Water table. Water table is what? Yes, the rainwater after the percolation through the soil, it collects above the bedrock, and this is the natural level of groundwater, which is called water table. All right. So this is the first property of soil, that is percolation rate of water in the soil. Now come to the second property. And the second property is moisture in the soil. All right, children. So this moisture content in the soil, we can understood it easily also with the help of a simple activity. Like we will take a boiling tube and fill it about 1/4 with a soil sample. All right, and heat it gently. So after taking a boiling tube, we will take how much soil? Yes, 1/4 of soil. And then we will heat it on a flame. And after heating, we will notice that the drops of water condensing on the upper cooler part of the tube. When it gets heated, the moisture which is present in the soil will get vaporized, and when it comes on upper surface, it get cooled, it get condensed and present on the form of water droplets. Get it? So they came from where? It came from the soil. And this shows that the soil contains water or moisture. Alright. Now feel the soil sample from which water has been removed by heating and compare with the original soil sample. So you will find some differences. Is it? The difference is the soil sample without heating is moist, while the soil sample after heating gets dry. Alright. And on a hot summer day, the vapor coming out from the soil forms a layer above the ground and reflects the sunlight and the air above the soil, which seems to shimmer. Get it? This is the reason that soil seems to shimmer because of reflecting the sunlight and the air by the layer of, yes, the water vapors. Get it? So this is the second property of the soil, that moisture in the soil. Now the third property, and the property is absorption of water by the soil. Absorption of water by the soil. This is the third property of soil. And this property can be easily understood while taking a funnel and fold and place a filter paper in the funnel. So first of all, we will take a funnel and we will place a filter paper in it. Alright. Now weigh 50 grams of dry powdered soil. How much soil will take? 50 grams of dry powdered soil. Okay, and put the soil on the filter paper in the funnel. In this filter paper, we will put the 50 grams of soil. Got it, children? Now, measure 100 ml of water using the measuring cylinder or a beaker and slowly pour the water on the soil using a dropper. Get it? With the help of a dropper, we will put here the water drop by drop and spread the water over the entire surface of soil sample and continue pouring until the water just start dripping from the funnel. Okay, as the water start dripping from the soil, we will stop the putting the water on soil sample. Get it? Now measure the quantity of water which is left over in the measuring cylinder. How much water is left? So suppose that it is 60 ml. Alright. So how much water is absorbed by 50 gram of soil? It is, yes. So we can say that we have taken 100 ml of water in the starting and left 60 ml. So the water which is, yes, absorbed by the soil is 40 ml. Alright, children. And as you know that the 1 ml of water weighs 1 gram. Okay, so the weight of water absorbed by the soil is 40 gram. Get it? Now, the water which is absorbed as percentage of the weight of the soil is about, yes, 40 gram, that divided by 50 grams, and then we'll multiply it by 100. And now we'll get the percentage of, yes, the weight of the soil which absorbed the water. So the answer will be there 80%. Alright children, 80% water absorbed by the 50 gram of soil. Get it? And will repeat the same activity with the different types of soil samples. Alright? So, which soil will absorb the maximum water and which soil will absorb least water? So, children, as you have studied already the different types of soil, okay, and different types of soil have the different size of particles. So, sandy soil absorbs less water and allows more water to percolate, whereas clay soil absorbs more water than sandy soil and allows less water to percolate. And the reason you know very well that sandy soil, the size of the particles are bigger as compared to clay soil, and the clay soil have very fine particles. Okay, so that is why clay soil will absorb more water than sandy soil. Alright children? Now, as you have already seen that the sandy soil cannot absorb much water because of large spaces between the soil particles. And on the other hand, the clay soil absorbs and retains a lot of water. In fact, in areas where there is a lot of clay in the soil, stagnant water collects above the soil whenever it rains. Okay, and this is known as water logging. What this condition is known as, children? It is known as water logging. Okay, and in marshy areas, the soil is always waterlogged, and the waterlogged soil cannot hold air for roots to breathe, and plants cannot grow well in it. Okay, so this is the drawback of, yes, waterlogging areas. The areas where waterlogged, the roots of the plant not breathe because they not give the sufficient air. Okay, and that is why it cannot grow well. Alright, so these all are the properties of soil, and I hope that you understood these all properties. Okay, now come to the next topic of the chapter, that is soil and crops. So children, here we'll discuss about the relationship between soil and the crops which are grown in that soil. Children, different types of soil are found in different places that you know very well, and the main factors that affects the type of soil found at a place are kind of parent rock, plant cover, and climate, that is temperature, rainfall, humidity, sunshine, and wind. Okay, so these all are the factors that affect the type of soil. Alright, now the type of soil and the climatic factors of a place, it determines the plants that can grow well there, and hence the kinds of crops that can be best grown in the region is the clay and loamy soil are both suitable for growing wheat and gram. Alright, for the crop of wheat and gram, which kind of soil is suitable? Clay and loamy, because the clay soil is made up from very small particles and that can hold more water. Alright, paddy, it requires soil rich in clay and organic matter, so with a good capacity to retain water. So paddies can grow in which kind of places? Yes, where the clay soil is present, because it can hold more water, it have good capacity to retain the water. And for pulses like dals, The loamy soil that drains water easily are best. Alright, for the crop of pulses, loamy soil is best because, yes, it drain water easily. And for cotton crop, the sandy loam soil is best. Sandy loam soil, yes, that loam that has more sand is known as sandy loam soil. So, this sandy loam kind of soil can hold air, but water can drain through it easily. So, this is why this kind of soil is best for cotton crop. Get it? So, the different types of crops grown in different types of soil. Alright, children? Now, the soil is a natural resource because it is present naturally in the nature. So we will discuss now some of the uses of the soil for our life. Alright? So our next topic is soil as a natural resource. Children, a natural resource is anything that comes from the earth and used by us. Is it? So it is known as natural resource, and soil is our most important natural resource. Alright? And it is useful to us in many ways. So the first way by which the soil is useful to us is, yes, we depend on the soil for food, clothing, and shelter. Get it? Now, by supporting growth of plants, the soil provides us with food. Much of our clothing, such as cotton and wool, and can be traced to the soil. And the plants also provide us with medicines, fuels, paper, and wool, which is used in making furniture and for constructing houses. Get it? So we can say that yes, we depend on soil for these three purposes, that is food, clothing, and shelter. Alright? Now, the next one is yes, we depend on soil for minerals. Alright? That industries use the minerals that dug out from the earth to extract metals such as iron, gold, silver, etc. And for use in thousands of industries that produce various useful things for us. Alright, these minerals are used by different industries to produce the different substances like the minerals such as coal, petroleum, and natural gas. They are obtained from the soil and provide us with fuel and many other useful things. Get it? And the second, we depend on the soil for clay, which is raw material used to make bricks, tiles, pottery, and porcelain. Get it? So these different minerals are used in different industries which are very useful for us. Alright, children. So these are some of the useful ways of soil that we are using it, and rest of the natural resource of the soil that we'll discuss in the next class. Alright, children. Thank you and have a nice day.